Hello everyone, welcome to video lecture on software architecture and design pattern. Today we are going to discuss third module, design pattern catalog. We have seen there are two drawbacks, so that we should overcome by using this bridge design pattern. Actually the bridge design pattern addresses these problems by putting the window abstraction and its implementation in a separate class hierarchies. So that is the a major role of this bridge design pattern. There is one class hierarchy for window interface, for example window, icon window or transient window in the next coming diagram, and a separate hierarchy for platform specific window implementation with window IMP as a root. So we should consider as a window IMP as its root for hierarchies or parent node, we can say. The X window IMP subclasses, for example, which provides an implementation based on X window system. So here all the operations which on a Windows subclass which will be implemented in terms of abstract operations from the window IMP interface, that is the root window IMP interface. So this actually what it does, decouples the window abstraction from the various platform specific implementation. That is the we had intent or purpose of the bridge design pattern. So next we will move on to this graphical representation. So we will tell that, so this is the see this the bridge shape. So we have formed that is the loop, or we can say the rectangular this shape. We have made it a bridge connection between this window IMP window class to window IMP. This is the main interface we had implemented, that is the root. We had called it as a root. So this window, this is the two operations here: draw text, draw rectangle. So when you call this operation, so obviously which will call the this we are going to do that IMP, that is the DVE, that is the device draw line, and device draw line, and device draw line, and device draw line. So when you call this rectangle like this, when we operations, all the method will be getting to executed. So in according to this bridge design pattern, because we have made this interface abstract implementation, we have made the window IMP as a bridge for this one. So actual window of this, so which will have the separate class implementation here. So that is the what does it. So this actual window will be implementing that icon window with the operation draw border or draw rectangle or draw text or whatever to show it is. Another one is transient. So transient window, that is draw close box and draw rectangular the things. So here in case of another separate abstract implementation of window IMP, if you consider this X window IMP and PM. So PM window IMP. So here device draw text, again device draw line, and device draw line, device draw text of the particular operations will be adopted here. X draw line and X draw the string of type is the window IMP and window X window IMP. So this is a structural just representation. This is the what we indicate. We refer the relationship between the window and window IMP. This window, this is the calling to this window IMP. So one more abstract implementation, that is the this is called as a bridge. So the once we make this bridge, this will have a separate again sub classes which will call a particular whatever the methods and necessary object will be having. So this is the major main thing of the Windows what we can say, that is the window class. That is the major role of bridge classes, or whatever that all operations here we can window subclasses which implement abstract operations, mainly IMP window IMP. So this is the window IMP implementation or interface implementation. So our next intent after this motivational, next template sections, that is the applicability. Use the bridge pattern when you want to avoid a permanent binding between an abstraction and its implementation. So this is the one situation whenever we want to binding the, so permanent binding between abstraction and its class implementation. So that time this bridge is very helpful for, that is the making the uh, class in or subclass or the interface implementation. This might be the case because, for example, when implementation must be selected or switched at the runtime, very useful in such cases. Another, so use the bridge pattern when both the abstractions and their implementation should be extensively by subclassing. So this is a good example. We are doing windows having their own subclassing, and it abstract implementation, that's window IMP having X window, PM window, that is their own subclasses. So in that cases extensively by subclass. In this case, bridge pattern lets you combine the different abstraction and implementation and extend them. All the particular part will be like icon window, transient window, X window, PM window, XW, or that's the X window, PM window. So all will be in the independently. So that is the role of this bridge design pattern. Another, use the bridge pattern when changes in the implementation and abstraction should have no impact on client. So this is need to be considered, because whenever there is an implementation of abstraction should have a always no impact on the client. Whatever the client expect, he can expect or he can access all the details, but there is no impact, no changes in the further what is the implementation of particular abstract classes. So that is the main thing, that is that the code should have what is have to be recompiled. Okay, so now that is the main, their code should not have to recompile, not required to compilation. So use the bridge pattern again when C++, you want to hide the implementation, that is the data abstraction. We know that hiding the data from the abstraction completely from the client. So this is the in case C++ representation of class is visible in the in case of the particular interfaces. Another thing, use the bridge pattern when you have a proliferation of classes, or their earlier first motivation diagram we had seen that such a class hierarchy, whatever that indicates that one an object into the particular object into the two part. So that is the one consideration. Another part, so we need to take the structure. Another part is the intent, what we have the intent sections, that is our actual motivational example will be always main structural part. So this year we are taking the their participant what and all will be there, that is the actual structural diagrammatical representation of bridge structural design pattern. So this is called a structure. So here this is not visible, this is the client, what the client expect. Okay, so the abstraction is we had that is a window we had. So in this implementer we have taken, in this implementer is the window IMP, the abstract this example, this will call abstraction will implement this window implementer. So here the operation IMP will be there, and this subclass will have the refined abstraction, and this will have their own separate concrete implement A and B respective operations again operation of this whatever that here this operation will be taken. This is the particularly we can say that is the structural diagrammatical representation of uh, bridge design pattern. Next, move on to the so what and all participants. So what and all participants are there in the structural design pattern? So that we need to see that. So here we have taken participant one is abstraction. So that is the abstraction is specifically we have taken that is a window. So what it does actually, which defines the abstraction interface whenever it is required, and which abstraction and or window which maintains a reference to an object of type, whatever the type of the implementer, x icon window, pm window, so and so, whatever it is that we have taken for the abstraction window. Next one is in the participant are that is usually you can call icon window, or here refined abstraction, or this is the icon window. What it does, which extends the interface defined by the abstraction. That's very simple. Actually main abstraction class we have a abstraction class, that's the window will be extend, that is the icon window, whatever that one which below that one may have taken. Next one is implementer. This is the implementation class. So implementer is the what we have taken, that is in the motivation as in a window imp. So window imp implemented in terms of the abstract what is the abstract operation from the window imp. This is the window imp is the what you can what is the implementer, or window imp is the implementer, we can you can call it the interface implementer. So that interface is what it does, defines the interface for implementation classes. This will have again followed by the different classes. What type of classes? Yeah, here we have that. One is the concrete implementer, that is the x window imp are subclasses of this implementing interface. This interface window imp interface, pm window imp, again this is the subclass of this window imp. So these are the actually participant. Typically an implementer interface which provides only primitive operations. So an abstraction defines always a higher level operation based on the these primitives. So what type of primitives we are going to use? So that will be taken into the part. Simply this concrete implementer that we have taken implements the implementer interface. Actually this is going to implement the implementer interface and which define its concrete implementation. So this is about what we had, that all the participants of this structural design pattern which contains abstraction, that is called as window, refined abstraction icon window, implementer window imp, concrete implementer that is called as x window imp comma pm window imp. Okay, next we'll move on to the next part is collaborations. Is it there any collaborations of the bridge structural design pattern? So we'll see that what type of collaborations we'll have in this design pattern. So which implements that whatever that one we have taken to a particular interface. So these collaborations in terms of abstraction forwards the client request to its implementer object. In that case only we'll have this kind of collaboration, other than nothing will be there in that one. And we need to see that next intent or next our format sections are consequences. So here actually the bridge pattern has there are the following consequences we have taken. There are 1 2 3 major consequences. First one is decoupling interface and implementation, improved extensibility, hiding implementation details from client. So we'll take this one. First one is decoupling interface and its implementation. What does it? What is the consequences this bridge pattern? So when you take this part here, an implementation is not bound permanently to an interface. That we need to count. We need to keep in our mind. An implementation is not always bound permanently to an interface. That is the major thing here. Implementation of abstraction can be configured at the runtime. So it is even possible for an object to change its implementation in the runtime. It is a possibility is there in the actually decoupling. Decoupling abstraction implementer also eliminates the compile time dependency on the implementation. Changing an implementation class actually it doesn't require recompiling the abstraction class and its client, not required. Actually this what is the this property is essential when we want to have it in the particular binary compatibility between the different versions of the. It depends on the what type of the library what we use. All part will be consideration of this particular bridge pattern consequences. Second one is improved extensibility. So what does it? When you can extend the abstraction, yeah, we had seen in the previous diagram when you had extended the extraction in the IMP window, window IMP, yeah. So abstraction and implementation hierarchy always it independently. Their hierarchy always completely different from the what we had the first our window class or Windows main inter classes. Similarly, another one is hiding implementation details from the client. So this is we client is from implementation details like sharing the implementer object and accompanying reference to the count mechanism if any. So hiding all the implementation details from the client. So that is main consequences in the bridge pattern. Whenever we need to have a sharing implementer object will be taking into the consideration. So these three are the bridge pattern consequences. One is decoupling interface, implementation, improved extensibility, hiding implementation details from the client. The next one is implementation. The next our template part is the implementation of bridge structural design pattern. So consider there are following implementation issues when applying the bridge pattern. So whenever we apply this bridge pattern, these implementation issues need to be considered. So one is only one implementer. The second one is creating the right implementer object. Third one is sharing implementers. Fourth one is using MI, multiple inheritance. Okay. So the first implementation issues when applying the bridge pattern, only one implementer. What does it and what are the issues we have that only one implementer cases? So where the situations, there are some situations there is only one implementation. So creating an abstract implementer class is not necessary. So that is the issues will be considered, because whenever one implementer will be there, we no never need to create an abstract implementer, not necessary, because one implementer, this the issues will be considered while applying the bridge design pattern. This is the actually degenerate case of the bridge pattern. There is one-to-one mapping, the relation between the abstraction and implementer. So that's why we have to consider these issues while when or applying the bridge pattern. So the next one is creating the right implementer object. So these issues, when we need to does have this, or does contain the what does it, how, when and where do you decide which implementer class to instantiate when there is a more than one implementer object. So, for example, an abstraction knows about all the concrete implementer classes, then it can instantiate one of them a constructor. So, it can decide between them based on the parameter what we passed to its constructor. For example, a collection of class support multiple implementation in the decision can be based on the size, what are the size of the collection, how many object will be, and linked list implementation can be also used to particular collection, and hash table also for the large one collection. So this is the another approach, part of the creating the right implementer, when to create or where to and how does it works. Another approach to particularly choose default implement initially and change it later according to the particular usage. For example, if the collection grows always, which is increasing bigger than the certain threshold, we should collection of the object put have, we should put a threshold. If that crosses or increases or switches implementation to that one more appropriate large number of the items. Another possibility is that to delegate the decision to another object altogether. This is the P in a window or window IMP is an example. In the case this example, we can introduce a factory object, that is the abstract factory, which comes under another design pattern. So actually, this is the encapsulate the actual platform specific in use that abstract factory. So like that, what the benefit what we have approached this, which is not coupled directly to the particularly any one of the implementer classes. So that is the issue we need to consider. What is the right implementer object, where to apply, when to apply, and what actually how and how what does it, where it is can be applied. Now the third one is the implementation issues. Whenever we are applying the bridge design pattern is using MI multiple sorry, sharing implementers. So sharing implementer, so that how we can that actually body of the entire body stores the reference to account that handle classes, body or handle the classes which increment or decrement, the code assigning the sharing implementer, assigning the handles with the shared bodies in the we have a certain form of that one in the segment of code here. Handle operator or constant, actually body will be unreference will be taken if the body reference count equal to 0, and delete body. Similarly, the body equal to other body, and return this pointer will be taken. How it is going to sharing the implementer, how you are going to actually share the implementer. Now the last one is using multiple inheritance, MI. So we can use multiple inheritance CPP or C++ to combine the interface with its implementation. An example we can take here, a class can inherit publicly from the abstraction and privately from the concrete implementer we had seen in the our motivation example. But this approach relies on a static inheritance, but it binds an implementation permanently to its interfaces. So therefore, always we cannot implement a true bridge with a multiple in MI. At least particularly not in the C++. So these issues will be we need to consider whenever we are applying the what is that one applying the bridge design pattern. The next part is the sample code. So we have not taken the sample code. Again, the segment of code is the C++ code to implement a window or window IMP. An example from the our motivation section or motivation example. So window class actually which define a window abstraction for the client applications. So that is the class window and public window view content will be taken. So actually request handled by the window different void open close iconify de-iconify and request forward to the implementation is the particular point at set origin extent rise lower and draw line draw rectangular draw polygon draw text, so which will be has taken in the particular segment of data. So window maintains the reference to window abstract class that declares an interface to the underlying window system, that is the class window or public. So we have taken virtual void top bottom or point that is we have taken set extent and set origin. So that is the, again device rectangle device rect. So all will be taken in terms of the sample code. Similarly, the next one is the code like that PM window. So icon window, how it can store the bitmap icon display, and PM window presentation manager window which defines the PM window class. How we are going to define the class X windows subclass which support the particular X window, and PM implementation which we have taken the PM window of all the left right left all the top particular bottom X coordinate Y coordinate X0 XY. So all the coordinate values will be taken in the particular uh, code pattern. So next is the noun user. Actually the noun user window, an example comes from the ET++, and window IMP is called the Windows port which has a subclass such as X window port or Sun window port. So ET++ window port actually design extend to the bridge pattern in that window port also always keep reference back to the windows. So like this we have a related patterns. So actually what is the related patterns of this bridge structural design pattern is an abstract factory, so can create and configure a particularly almost related to the bridge pattern. So this is about the all the format of template sections of the structural bridge design pattern. So next we will move on to the next structural design pattern is composite. So this is the composite structural design pattern. The purpose or intent, main aim of this design pattern is compose an object into tree structure to represent part whole hierarchies, part or whole hierarchies. Actually, composite lets client treat individual object and compositions of object uniformly. So that's the specialty of this composite pattern. Complete actually composite lets the client treat as an individual object and composition of object uniformly. So this composite design pattern doesn't have the another section that is also known as, there is no well-known name or suitable name for the composite design pattern. Directly we will move on to the our motivational sections of template, that is the motivational example we are going to take. One is graphics applications is a major part we have taken in this an example. Okay, graphics like drawing editor and schematic capture system like build a complex diagram out of we know that simple component user group component from the larger component when grouped into still larger particular. A simple implementation could define all the classes graphical primitives such as text line plus other class that act as a container of these primitives. But what will happen? There is a problem with this approach and usual as a what we have taken in the a simple implementation. The problem is a code that uses these classes must treat a primitive and container object. Always object is the container object is separately or differently, even if most of the time user treat them identically. So having this distinguish of this object makes we can say that application more complex. In such cases, it is really difficult. So here, what does it actually the composite design pattern describe how to recursive, how to use the recursive composition so that client do not have to make this distinction. So this is the added advantage of this composite design pattern. So particularly composite pattern describes how to use recursive composition. Composition will be there in the different object, but how to use the recursive in the manner. Here client he don't have to make their distribution client distinction. Client cannot make the distinction or differences of that one. Directly he can access. So that is the added advantages. So this is the composite again client don't have to make this distinction. So now we will continue in the next part is the next videos.